Jai Hind everyone. My name is Muklit Goyal. I am assistant professor in Department of MCA. Today I am going to present my topic, which is mode of transfer in computer organization and architecture, paper code KCA 105. First of all, what are the contents of my presentation? First, I will explain what are the peripheral devices. Now, second is different type of transfers. Third, mode of transfer, which is of 3 types, and last is DMA in detail. First I would like to explain what are the peripheral devices. Basically, peripheral devices are those devices which we can call it as a combination of input devices and output devices, in which input devices are keyboards, optical input devices like card reader, barcode reader, optical mark reader. Next is magnetic input devices, which are magnetic strip reader, screen input devices, in which we can say touch screen or mouse, and output devices are card puncher, CRTs, cathode ray tube. Next is printer, plotter, and voice, in which we can say speaker. So these are the peripheral devices. These are the two categories of peripheral devices. One is input device and another one is output device. Now the second thing is how they communicate with the CPU or the main memory. Then there are two types of transfer. One is synchronous transfer and another one is asynchronous transfer. So today I am going to discuss asynchronous data transfer. What is the difference between the two? First, what is the difference between the two? The difference between the two is, what is synchronous? Synchronous means कि when we are sync with someone. Sync with means कि we are affected, we are communicated about the things which other is also doing. So like in CPU, what is synchronous means? Synchronous means all devices derive the timing information from the common clock line. And what is asynchronous? Asynchronous means we are not affected by the others. We are just doing what we have to do. So there is no common clock when we talk in terms of computer architecture. Okay, so I will explain what is asynchronous data transfer. What is asynchronous data transfer is? Asynchronous data transfer is between two independent units that requires control signals be transmitted between the communicating units to indicate the time at which data is being transferred. Means there are two independent units. They are not considered as a one in asynchronous, while in synchronous they are considered as a one unit and they will work on a common line. And in asynchronous they are considered as a independent units which will work on the separate clock. Asynchronous data transfer is of two types. One is stroke pulse and another is handshaking. Stroke, what does stroke pulse means? Stroke pulse means is supplied by one unit to indicate when the other unit transfer has to occur. In handshaking, the control signal is accompanied by each data being transmitted. So I will explain this in detail. First, I will explain stroke pulse. Stroke pulse, like in the diagram, they are initiated on two units. One is source initiated, another is destination. Means the information which we have to send is from the source, and where it will reach to destination. So how it will reach and what the role of the CPU and the memory, that I will explain. Stroke control means employ a single control lines to each transfer. Means when we want to send any information from the source, we want to send any information, consider it as a source, and that is need to be destination, that need to be sent on the destination, which is any peripheral device. So in stroke control, what is done? Through data bus we send some data, it reaches the destination, and so source just been only done that it will only send the data. It will send the valid data. In stroke control, source is nowhere concerned about whether the information or the instruction will reach the destination, but whether it will execute it at the destination or not. In stroke control, source does not need to know about that. So in stroke control, only work is the source will send the information. At destination will receive the data and send the strobe to source unit. So at the source, there is no botheration of the source unit that whether the data will reach or not, but destination will initiate that they will receive the data. So that is also seen in the timing diagram, that in stroke control, in source initiation there is no common line, but in timing diagram there is a common line between the data and the stroke. So why we need handshaking? First, we need handshaking because in stroke control, at the source initiate the transfer, and it does not have any way through which they know that the data is actually received by the destination unit or not. And same in the destination, at the destination end, the destination unit that initiates the transfer there is no way that it will know the source has actually placed the data on the bus or it has not been placed on the bus. So for this we apply another method which is known as handshake. Handshake method is same as we do in normal life. If we handshake with someone, we got to acknowledge from that one whether that person is interested in handshaking or not. The same as has been done on the computer side also. When source have initiate some instruction, it will load it on the bus, it reaches the destination, and it will also receive the acknowledge that data is accepted on the destination. The same way the information is initiated on two way, one is source and another is destination. So in handshake, as I told, source initiate the instruction, load the instruction on the bus, validate the data, and also receive the acknowledge that this data is accepted by the destination unit. As you seen in the timing diagram, first data is loaded, then data is validated. After validated, the data will reach the destination. Destination unit accept the data and send the information again to the data valid, and then again it will come into destination for execution. What are the sequence of events? First, source initiate the data on the bus and enable the data valid bit. Then after enabling the data valid bit, destination unit accept the data from the bus and enable the bit that destination has accepted the data. After that, source disable the data valid bit for that initiate, and destination initiate the data accepted, disable the data accepted, and now that ready to accept another data. So same way the cycle goes on. That is the source initiated. Now comes the destination initiated. In destination initiated, source send the data, valid the data. What destination will say? Destination will say that okay, now we are going to execute that information and we are ready for the execution of that instruction. So in timing diagram you see data bus through data valid, ready for data, then validate the data, then again ready for data, and then it goes for the execution. So the sequence of events in handshake is first data placed on the bus, enable data valid, and at the destination first you come to know that destination is ready to accept the data and enable ready for data bit. Then place data on the bus, enable data valid, then in the same way disable ready data, and it normally forms the initial state, and then again this cycle goes on. Handshaking provides a high degree of flexibility and reliability because you got the acknowledge that the data is valid and the destination unit is ready to accept the data and execute the data. So the data which travels through handshaking is more reliable. Now there comes the three modes of transfer. The first mode of transfer is program controlled input output transfer. Another is interrupt initiated input output transfers, and third is direct memory access. So what are these mode of transfer basically? These mode of transfer is basically for setting up a communication between the peripheral devices and the input output units. So program control input output in this mode, what we will do, that the data which we have to transfer are written in the form of computer program, and it is mainly controlled by the application softwares. The instruction written in the program basically initiates the data transfer to and from a CPU register and input-output peripheral devices. In interrupt initiated, in this mode, the method uses the interrupt signals to inform the CPU whether the data that are available from the peripheral devices, and the input-output flag is set to 1 when we want to receive a data. In direct memory access, we minimize the work of CPU, just limit the work of CPU to for the bus grant or to initiate the transfer. After initiation, the main communication is between the memory and that peripheral device on which the instruction has to be executed. Now, one by one, what is program control input output mode of transfer? In program control input output, the main work is between the CPU and input output device. Okay, first the address bus assign the address that goes between in the interface, that consists of the flags and data register. The operation which are executed is input output read operation and write operation. Data bus is two-way communication which communicate with the CPU interface. Now then the CPU, through CPU we got the information, instruction, that instruction need to be executed. Then data is accepted on input output device. Then input output device send a data valid flag. After sending a data valid flag, the data bus initiates the communication, and through input output bus is got executed on input output device. So how more than one instruction is assigned? More than one instruction is assigned through polling. In polling, there is a continuous CPU involvement. There is a least use of hardware because all the work is done through application softwares, but it will slow down the speed of CPU to communicate with the input output of peripheral devices. So after this we use, and what we done in this, the program input output transfer consists basically of 4 commands which are control, test the instruction, read and write. What is control? In control, we tell the peripheral device what to do. In test, there is a check condition whether what is the condition of input output of peripheral device, whether it is switch on, switch off, it is in working condition or it is not in working condition. In read operation, we send the data from peripheral to processor so that processor can read it and read it from the data bus and assign an address. Then write means send data using the data bus to the peripheral device. Input output modules perform the operations, and when those operations are completed, it updates its status register. IPU module, input output module does not inform CPU directly. CPU may wait for some delay. Okay, so it wastes the CPU time because the processors are much faster than input output devices. So bridging the CPU acts as a bridge for moving the data between input output module and the main memory, and CPU has to wait till the IPU module will complete the operation. Another one is interrupt driven input output mode of transfer, in which we overcomes the CPU waiting condition. There is an interrupt, there is a signal which tells the CPU to perform the operation, to perform the instruction. So which overcomes the CPU waiting time, requires setup code and interrupt service routine. There is no repeated CPU checking of device. Once the device is checked, then the CPU initiates the transfer, and it still requires the CPU to go between the data and input output module and main memory. So what is basic operations in interrupt input output? CPU initiates the process. Input output module gets the data from peripheral device. Input output modules interrupts the CPU, means send the signal to CPU, and CPU request data from input output, and CPU the request data input output module, that input output module transfers. So what is the CPU viewpoint in this? Device controller and other system hardware issues an interrupt, then processor finish the execution of current instruction which is going on, then processor signals the acknowledgement of interrupt, that interrupt arises, process pushes the program counter into control stack, then processor loads new program counter value based on interrupt. So this is the work by the hardware. And what software is doing? Software is doing the saving the remainder state of process. There are 5 process state, which is new, ready, running, waiting, and terminate. So we need that information in what state the process is. Then process interrupts, restore the process in state information, and restore the old value of program counter. So this work is done by the software. CPU issues the read command and start doing some other work. Check for interrupt for end of each instruction cycle. Okay. And in interrupt input output mode of transfer, there is no involvement of code. All work is done through interrupt signals. Input output module issues the interrupt request. Input output, after issuing the request, what is done, that work done is save the context on stack, means which I have shown earlier, key processor pushes the PSW and program counter onto control stack. So at that time, if the context is saved on a stack, what stack have? Stacks in the form of registers and flags. Flags are basically a 1-bit, use 1 bit to show the status. Then send the acknowledgement. So input output module can release the request. Next step is process interrupt by loading the address of instruction register into program counter. The interrupt must save the result of instruction register, because more than returning from because after returning from the interrupt it will erase all the indications that happened at that time and retrieve context including program counter. There is another type of interrupt which we call as a priority interrupt. So what is priority? Priority interrupt means ki which interrupt is need to be served first. Okay, so priority means determine which interrupt is to be served first when 2 or more requests are made simultaneously. It also determines which interrupts are permitted to interrupt the computer while another work is going on. Third is higher priority interrupt can make request while serving a lower priority interrupt, means if there is a accessing of lower priority interrupt, then if any higher priority interrupt works, then that request will be initiated first and the lower priority interrupt will go on a waiting state. So priority interrupt, how will we do? By the use of software, that is done by through polling. What is polling? Priority is established in order in which it is required by the devices. It is flexible. It is done by the use of software, and sometimes it goes very slow. So there are 2 ways of doing a priority interrupt, either by the software or either by the hardware. In hardware, what will you do? Require a priority interrupt manager which accept all the interrupt requests to determine which is the highest priority interrupt, higher priority request, and which one is lower priority request. After that, it is much faster than software priority interrupt, because the higher since identification of highest priority interrupt is identified by the hardware and it directly loaded into their service routine. Now I will show. There is an address 0123. There is an interrupt through by keyboard. Okay. So what memory is doing? Jump to the disk jump to the printer, jump to the character reader, or jump to the keyboard. Jump to means which priority we have to, which instruction or which device we have to follow. So there is a program in which there is a current instruction at address 750. Now when interrupt arises, so what is servicing through input output service program. So if address is on 750, what we are doing, we initiate at line printer, or we initiate at character reader, or we initiate at keyboard. So first keyboard interrupt enters when current instruction is going at 750. Then 750 address is through keyboard. Okay. Then after that, we acknowledge the program to service keyboard. Then from service keyboard, it will goes to the disk. Then after disk, it will come again to the input output service program, from where it will get the information on what disk we are servicing. Okay. From that, we come to that address, then again come to the memory and initialize the stack address. Okay. Then we store the last address, which is 750, and then we execute that instruction on which the interrupt occurs. Now, why we need direct memory access after interrupt? What we are doing in interrupt is we are doing polling, and through interrupt we are concentrating on data transfer between the processor and input output devices. Through direct memory access, we minimize the work of CPU. And what we can also do through direct memory access, we can send a large blocks of data. Okay. So, and between which we are transferring that data, that is between the external device and the main memory. In direct memory access, the CPU work is only to initiate the transfer. Okay. So I will define all the transaction details. What we have to do, device wishing to perform DMA asserts the processor's bus request signal, that there is a request signal to which process, on which device we want to execute an instruction. Now processor complete the current bus cycle and then asserts the bus grant signal to the device. What is the bus grant signal? Bus grant signal means we are assigning the address and loading the data on the data bus. The device then asserts the bus grant signal. The DMA performs the transfer from the source to the destination address. Once the DMA operations are completed, the device releases the bus by asserting the bus release signal, means then the DMA will give the signal that now we are releasing the bus, so another data can be loaded. What processor acknowledges the bus release and resume its bus cycle from the point it left off, means where it is started. Now I will show it by using a diagram. First, CPU set up the memory transaction on DMA controller. From DMA controller, it will go to the RAM. Then from RAM, it will go to the data transfer or any storage device. What is GPU? GPU is general process input output units. They are connected to the CPU through a address bus or data bus. Through that bus, the RAM will acknowledge the DMA that they have accepted the data. The interrupt will occur on the processor, and when the interrupt occurs, the data will hold for some time till the bus signal is released. So what DMA performs the transfer from the source to destination, and if the operation is complete, then we release the bus release signal. Okay. What and how it is done? It is done through the buffers. Most DMA have the data storage buffer peripherals that can send the transfer, then that send a burst of data faster than the main memory can handle. So what is bus arbitration? Bus arbitration is arbitration means the intermediate. So in this communication, what is the intermediate medium? Intermediate medium is the bus, and the bus might be the data bus, address bus. Okay. So bus arbitration is needed to resolve the conflict with more than one device. Each device is connected through a bus. Then what is bus master? Bus master means that controlling of the control signals. Bus master means bus will told the memory or the peripheral devices to send the data. Bus master is a device that is allowed to initiate the bus transfers on the bus at any given time when the current master relinquishes control and other devices that control that status. And the bus arbitration is the process by which the next device to become the bus master is selected. It is of two types. One is centralized, in which a single arbitration performs all the mediation work, and the distributed, when the devices participate in the selection of the next bus transfer. Now, how this is the block diagram or the signals, how the CPU signals for the DMA transfers, and how the block and how all these are initiated into the peripheral devices and the CPU and the memory. So what CPU does only one thing, which is CPU bus request and bus grant. What is connected through CPU is address bus, data bus, and two operations, which is read and write. What DMA is doing through address bus buffer connected through data bus buffer, which is connected to internal bus. From peripheral device, we do two things. One is DMA request and another one is DMA acknowledgement. When it goes to the control unit, one is DMA select, means direct memory access select, now on which register, then read and write operations, then bus request and bus grant. The bus grant has been done through CPU, which I will show in the DMA transfer image, and the interrupt. Now, this is the DMA transfer. Input output peripheral device done a DMA request. In DMA controller, we will receive a bus grant from CPU and we will tell the bus request to CPU. When we tell the CPU for the request of a bus, then CPU grants a bus to us. We will do a read write operation through a register select and data select, which is done on the basis of address bus. Address bus is connected to the CPU and the memory unit, and what we have to do, all those functions controlling is done by the CPU and the memory. So read control and write control, and when in the interrupt arises, it will tell the CPU. The interrupt directly will not communicate with the memory. So in this way, DMA sends the request, and when that request is granted, then acknowledge to the input output peripheral device. How DMA can be done? DMA can be done through three techniques. One is block transfer, in which we transfer the large block of data, whole block we transfer in a one go, and CPU can do non-related bus activities in the meanwhile. Means CPU does not need to be busy. In cycle stealing, what we do, DMA control freezes the CPU and then initiate a word by word transfer. And in interleave, the DMA controller uses the CPU cycles that are not using the bus and letting the DMA refers and CPU use the do the alternate use of the bus. That's all for today. Thank you.